Hi, I'm Michael Faraday. Today, I'll be pitching my DC motor to you. Electromagnetism works by running a current through a coil. Note, in this lab, I had to scrape off half of one side of the coil to turn off the magnetic field for half the rotation. Because both a current and a magnetic field are present in the motor, we can use Fleming's left-hand rule to determine the direction of the force.
Faraday's law. This law states that in a closed loop of a wire, a change in the magnetic environment causes a voltage, also known as EMF or electromotive force, to be generated inside the coil. The formula is written as such. E or induced voltage is equal to negative and the number of turns in the coil times the change in magnetic flux divided by the change in time.
To complete this lab, I used a breadboard, wire, coil, sandpaper, paper clips, magnets, resistor, and a voltage source. Here's a picture of some of the materials I used. Lab procedure. First, I bent 2 paper clips and placed them onto my breadboard. Then, I took my coil and completed 14 rotations. After threading the coil, I sanded down half of one side of the coil using sandpaper. Next, I created a magnetic field using 2 more paper clips and 4 magnets. Then, I added the resistor and wired the motor to its respective charges. Finally, I connected my motor to the voltage source. Now, let's discuss why this motor is important. First and foremost, it lets us convert electrical energy into mechanical energy, specifically rotation. The speed can vary depending on the electrical input and design. This simple but important invention could help in the design of future applications such as tools, toys, household products, machinery, and much more.
Hopefully by now I have convinced you of why this invention is so important. I've shared this with you in hope that one day this will be used in our everyday lives. Thank you for your time. It has been a pleasure.